So again, the concept that we have here is uniformly minimum variance unbiased estimator. Okay, that means you need to compare which data ataupun which dia punya estimator is the best. Okay, so what we use here is the Cramer-Rao inequality. Okay, so all is depends on your Cramer-Rao lower bound. Okay. So again, if you have your variance data here, okay, after you already prove that your theta here is unbiased estimator, okay, first step, show that your theta here is unbiased estimator. Okay, second step, you find your variance, the variance of your theta here. Okay, third step, okay, use the formula to find the Cramer-Rao lower bound. So kalau let's say if you get variance theta here greater or equals to your Cramer-Rao lower bound, so that means your theta here attains the Cramer-Rao lower bound, so it must be uniformly minimum variance unbiased estimator. Okay, so itu macam mana kita define. So this is the method how you can derive the Cramer-Rao inequality. So starting by you have your PDF fx theta, and then we take derivative, and then kita samakan lah, kita denote, kita modify, and then we express the term in terms of ln. Okay, because when we differentiate the ln, we'll get back this value. Okay, and then so this one 1a, equation 1a is the same thing if you write expected value d ln fx theta over d theta. Okay, because ini set equal to 0 lah sebab sebelah on the right hand side. Okay, so the same thing if you want to find your ex, x times your probability. So ini pun sama, expected value of this one, so d ln fx theta times your probability function. So that's why we can write that one in terms of expected value. Okay. Okay, so again, second step tu dia differentiate again. Differentiate again. Okay, and last we have this term, kita ada d ln fx theta d theta and then square fx theta. So this one we denote sebagai I theta. Okay, I theta here is your Fisher information. Okay, we call that one as Fisher information. Okay, so the same thing. You can also write in terms of your expected value. Okay. And then the same again, kita go back kepada equation 3, and then kita boleh express juga I theta ni in terms of negative, tapi kita ada d square ln fx theta d theta square. Okay. So since you have d square ln fx theta d theta square multiply with your probability function, so it can also be written in terms of your expected value. Okay. Finally, bila kita dah equate and so on, kita boleh simplify kan, kita ada negative expected value d square ln fx theta d theta square, sama juga kalau kamu dapatkan expected value d ln fx theta over d theta square. Okay, but this case is only when you have one sample size. Okay, that means your n is equals to 1, x sajalah. Yeah. Kalau kita ada xi, kita akan ada summation. Okay, when you have summation here, so it becomes n I theta. I theta ini yang tadi tu, either in terms of negative ataupun this one. Okay. So the information in a random sample of size n is just n times the information in a sample of size 1. So in order for you to get your Cramer-Rao lower bound, okay, so let's say you have your S1, S2, Sn random sample. Okay, BIID ni maksudnya independent, identically distributed. Okay, for statistic, if you do further study, okay, we need to verify lah, is it your data is independently, identically distributed. Okay, sebelum kita start proceed with our analysis, normally we need to verify lah. Especially if you're doing for your master by research or PhD, kena verify lah, because that is the theorems that hold for in case for this one, Cramer-Rao lower bound. Okay. So again, sini kita ada variance y greater or equals to k prime theta over ni theta. So katakanlah k theta kita equals to theta. So that's mean k prime theta. So differentiate theta, it just give you 1. Okay. So your Cramer-Rao inequality becomes variance y. Okay, variance yang kita dapat tu variance y, which is your y tu it can be theta hit kamu, unbiased estimator tadi, variance theta hit. must be greater or equals to 1 over ni theta. So kita kena provekan this one. So kalau kita dapat variance y greater than or equals to 1 over ni theta, so that means your y here, yeah, attains the Cramer-Rao inequality ataupun attains the Cramer-Rao lower bound. Kalau kita dapat variance y less than, so that means in this case your Cramer-Rao is not applicable. Okay, maksudnya dia tak attain lah, kamu punya unbiased estimator tu is not uniformly minimum variance unbiased estimator. Okay, dia hanya attain kalau kita ada variance y greater than or equals to 1 over ni theta. Okay, so here I theta tadi kita dah derive, so I theta kita substitute kembali, which is in terms of your expected value. But it can be written in terms of two case lah. It depends on your derivation of your ln. Yang mana yang lebih mudah, kamu buatlah. Kalau let's say yang mudahnya square, squarekanlah terus. Kalau mudahnya differentiate second time dulu, lepas tu baru dapat expected value. So buat yang itu dulu. Yeah. So this one you have n expected value d ln fx theta d theta and then square. So this one to the power minus 1 lah sebab kita ada 1 over ni theta. Kalau this one d square, so that means negative n kat depan. So that means if your variance theta attains the Cramer-Rao lower bound, which is greater than or equal, so it must be uniformly minimum variance unbiased estimator. Okay, kalau dia attains that Cramer-Rao lower bound. Okay, so itu first step dia, macam mana kita nak dapatkan uniformly minimum variance unbiased estimator. Okay, but again after we go to chapter 2 later on, yeah, there is several ways how you can get ataupun verify that theta head is uniformly minimum variance unbiased estimator. Okay, it's not necessarily just using Cramer-Rao lower bound. Ada alternative different ways lah. Okay, to find the uniformly minimum variance unbiased estimator. Okay, example 1.14, we already discussed this one. Yeah, so this is the Bernoulli distribution. Bernoulli, when you have your n equals to 1, you only have your parameter here is parameter p. So your x here takes values 0 and 1. You want to show that this one is UMVU estimator of p. First, you need to show that this one is your unbiased estimator. Okay, kita dah buktikan, kita dapatlah expected value of pH sama dengan p. So expand the formula, you have summation Si, so S1, S2, Sn. So kita ada p, so altogether np over n. So the same thing for variance. You have variance summation Si over n. So follow the properties for variance. Kita ada 1 over n square. Yeah, and then the same thing lah. Kalau kamu ada binomial distribution, you have your Ex is np, your variance is np1 minus p. So the same thing for Bernoulli distribution. Kalau kita ada variance for Bernoulli, that means p1 minus p. So that's why you will have here is just np1 minus p over n square. So cancel out, dia akan memberikan nilai p1 minus p over n. Okay. So this is your variance. Itu kita dapatkan dulu apa dia punya variance dia. So second step, kita gunakan Cramer-Rao. Okay. So ambil just ln fxp. Okay, x ln p plus 1 minus x ln 1 minus p. And then differentiate with respect to p. Okay. So kat sini saya differentiate again for the second time. Okay, differentiate again. And then I take the expected value. Baru dapatkan expected value ya. So since again lah Ex dia p saja. Okay, sebab x is Bernoulli. Okay, and then you get lah expected value 1 minus x. And then kita replacekan. Okay, kat sini So expected value of this one. So kita ada 1 minus p. So simplifykan semua ni. And then you get negative 1 over p1 minus p. Okay. Now the whole formula is negative n expected value d square ln fxp dp square to the power minus 1. Okay, negative n. So cancel out. It becomes positive to the power minus 1. So it can be written again back p1 minus p over n. So dalam case ni kita punya variance pH yang kita dapat sebelum ni, okay, kaedah this one adalah sama dengan yang kita dapat daripada Cramer-Rao lower bound. So that's mean in this case you can conclude that your pH is uniformly minimum variance unbiased estimator of P. Okay, itu dia punya prosedur dia. So maksudnya dalam solution kamu, you need to verify first unbiased estimator. Second, check what is your variance. Okay. The third one, use the formula, find your Kramer lower bound. Itu dia punya prosedur dia. Okay. So let's say we proceed with this one. Okay, this one is again exponential distribution. Okay, exponential distribution. You already done this one before. You already find what is the unbiased estimator for that one. Okay, kita nak compare Kramer-Rao lower bound with the variance of the MLE for theta head. Okay, so in this case, your theta head is just summation SI over N, which is your S bar lah. So show that theta head is the first. We need to show that theta head is the best estimator of theta. Okay, so again, this one we already have the information from the previous exercise. Kita dah tahu kalau exponential distribution, you will get your EX is equals to theta. Okay, kita dah buktikan ni soalan ni. Okay, so now you want to show that theta head is the best estimator. So your theta head, we need to verify whether this one is equals to theta or not. So the same thing. Kamu dah ada summation xi over n. So again, you will have 1 over n e summation xi. Okay, summation xi, x1, x2, xn. Okay. So again, kita dah ada expected value of x is equals to theta. So that's mean if you get ex1 is also theta, ex2 pun theta, sampailah kita ada exn. Okay, cuma tunjukkan dia punya jalan kerja lah. So you will have 1 over n. Here theta, theta, sampailah kita ada n theta. So all together you will have n theta. So you cancel out. This one will give you theta. Okay. So in this case, your theta head is the unbiased estimator of theta because we get expected value of theta head is equals to theta. Okay. So next, you show again variance theta head lah. Ini dah simple, variance theta head. Okay. So kalau tak pasti, again here, kita nak tunjukkan okay, you want to show that variance theta head. So theta head kita dah ada summation xi over n. Okay, again back follow the properties for variance. Kita ada 1 over n square. Okay, variance summation xi. Okay, summation xi, that means x1 plus x2 plus xn. So kau kembangkan lah. Okay. So kita ada variance x1, variance x2 sampailah you will have variance xn. Okay, variance x dalam kes ni apa? What is your variance x? Apa variance x for, what is the variance for exponential distribution? Apa variance dia? Sebab ini fungsi ni adalah fungsi exponential. This is exponential distribution. So what is the variance? What is your variance x? Kalau tak sure, dapatkan dulu nilai variance. Nadia cakap 1 over theta. So yang lain, what is your variance x? Is it you accept the answer by Nadia? 1 over theta? Kalau tak pasti, dapatkan dulu. Apa dia punya nilai variance dia?
1 over theta square.
1 over theta square. Okay, cuba kita buat jalan panjang. Okay, sebab ada yang 1 over theta square. Jalan panjangnya, okay, EX kita dah tahu, theta. So sekarang ni cuba guna basic formula Basic formula for variance. Kalau boleh ingat basic formula sebab dekat saya tak bagilah dalam list of formula sebab memang you know lah this one ini basic, very basic Especially bila kita ada Physical examination nanti. Kalau let's say online, still you can search through Google. Okay. This one variance x, ex square minus ex square. So, cuba dapatkan apa ex square dia. Cuba differentiatekan. Okay, kita buat jalan panjang. X square 1 over theta, exponential negative x over theta, dx. Okay. Okay. From 0 up to infinity. Okay, cuba kamu integratekan dulu. Bagi saya nilai dia. Apa ex square dia? Okay, dapat tak? Ex square. You solve by integration by parts. Cuba tulis dalam chat tu. Kalau ni. Anyone? Nampak tak soalan jawapan dia? You solve by integration by parts, what do you get? Ex square. Simple mathematics je ni. Yuan, nampak tak? What is your ex square here? Kita dah dapatkan dia punya variance. Yang lain, Badrul, do you get the answer? What is your EX square?
Saya tak jawab.
Cubalah dapatkan.
Tak dapat.
Tak dapat. Okay. Ini berapa tadi jawapan tu? 2 theta square. You get the answer? Vishan, you get the same answer with Hani?
Yes, I also get 2 theta square.
2 theta square. Make sure kamu dapat ini simple lah, kalau tak ni kena repeat balik method ni. Yeah. Just use simple integration by parts lah. Kita punya integration for statistik punya kelas ni biasanya taklah sampai tahap yang tinggi tu. Biasanya just simple takat integration by parts lah sepanjang saya mengajar MathStat and also Inferential. Itu je yang kita guna. Okay, kita tak adalah integrate yang pelik-pelik sangat lah. Yang double integration simple je lah. Cuma double integration biasanya fungsi yang simple. Okay. And then satu lagi integration exponential ni very important sebab biasanya soalan tu memang melibatkan fungsi exponential. So the same thing as in mathematical statistics. You need to know how to integrate exponential distribution. Yeah. So again, I already mentioned that exponential distribution, there are 2 types of writing. Okay, 2 types of writing. So this one is 1 over theta exponential negative x over theta. Okay, the other one is theta exponential negative theta x. So it's quite different. Okay, cuma yang tu mungkin dia ada 1 over macam yang Najibah jawab tadi tu. Okay. So the basic thing, if you not sure, go to basic lah. Macam mana kita nak integratekan x square. So ini saya tunjuk I just the answer 2 theta square. So in this case, you need to find what is your variance x. So dalam case ni, EX square is 2 theta square. EX kita tadi theta, so theta square. So you just get theta square. So this is your variance x. Okay, variance x is equal to theta square. Okay, now what you want to find is variance for theta head. Okay, kita nak dapat tadi adalah variance theta head. Okay, kita dah expand. Kita dah expand sampai sini. Saya off video Okay, variance theta head which is variance x1 plus variance x2 plus variance xn. So variance x adalah theta square. Variance x2 pun theta square. Variance xn pun theta square. Okay, substitute back in the formula. Okay, so you will have here 1 over n square. So in this case, you will have n theta square. So last theta square. Okay, so that is your variance theta head. Okay, variance theta head ni perlu dapatkan dengan betul. Sebab kamu nak compare dengan Kramer-Rao lower bound. Kalau kat sini dah salah, kamu tak tahu apa sebenarnya jawapannya. Okay, so please double check. So first, you get your expected value of theta head. You show that expected value of theta head is equals to theta. Okay, unbiased. Okay, property dia. Second, dapatkan dulu variance theta head tu apa. Okay, tunjukkan dia punya kaedah dia. So kalau let's say you already know what is your variance x, which is in this case is theta square, terus je lah substitute. Okay, but if you're not sure, boleh gunakan go back to basic, try to integrate and use the formula for variance. Okay, so that is your variance theta head. So now kita nak dapatkan pula Kramer-Rao lower bound. Okay. So this is the first step. You need to find your unbiased and also your variance. Okay. Second, kita set up for Kramer-Rao lower bound. Okay. So Kramer-Rao lower bound. So in this case, you already have your fx theta. To get your density function. Sorry. E exponential negative x theta. So kita startkan dengan, kalau kita tengok formula dia tadi, Kramer-Rao lower bound. Kita ada ln fx theta d theta. Okay, for a single variable. Okay, n dia kat depan. Okay, for a single variable. Jangan buat ln xi jangan ada yang summation dulu. So ini kita ambil ln fx theta for a single variable. So ln 1 is 0. So you get negative ln theta. X over theta. Boleh? Ni boleh simple je. Ambil ln. So ln 1 0 minus ln theta. Okay, exponential plus minus X over theta. So now kita differentiate. So differentiate ln fx theta d theta. 1 over theta. Differentiate minus x over theta. So theta bawa ke atas, theta to the power minus 1. So you get theta square. Okay. So katakan kita differentiate sekali lagi. Okay, differentiate second time. Theta, okay, differentiate this one, you get 1 over theta square. Okay, that one. Okay, double check dengan saya punya jawapan. Okay, sambil cuba buat. Jangan dengar je. Dengar je, tengok je kamu memang tak faham. Okay. Same thing, I derive, you also derive. Ini saya tak boleh nak tengok. So nanti lepas semester break kita berjumpa. So please make sure you know how to do this one lah. Okay, this one. Differentiate second time. So kita ada theta to the power minus 1. So inilah 1 over. Differentiate. You get 1 over theta squared. So this one give you minus 2x over theta cube. Okay, minus 2x. Okay. Now kita ambil dia punya expected value. Okay, expected value. So this one. Expected ln x theta d theta squared. Okay. So kita ada tadi 1 over theta squared minus 2x over theta apa tadi? Cube that one. Okay, so guna balik properties for expected value. So expected value 1 over theta square tu kita consider sebagai constant. So bawa ke depan 1 over theta square. Okay, so yang kita ada ini je. 2x over theta cube. Sebab x kita adalah random variable. Theta tu parameter je. Okay. So again, ex. Kita tahu ini adalah taburan exponential distribution. So ex tadi kita dah tahu, which is theta. Ex sama. Okay. Gantikan. So 2 theta over theta cube. Cancel out. Give you this one. So ini. Okay. So ini untuk expected value. So yang kita nak adalah Cramer round lower bound. Okay, Cramer round lower bound . So kamu ada, salin balik formula dia. Ni. This one. Negative n. Okay, to the power minus 1. Negative n. Expected value d square ln x theta d theta square. This one. So saya gantikan this one, you get negative n 1 over theta square. So you will get theta square over n. Itu kita punya value of your Cramer round lower bound. Okay, apa kita punya variance tadi? Variance theta head. Okay, kita dapat sini. Which is this one. Theta square over n. So dalam kes ni kita akan tulis biasanya kita akan tulis macam ni lah, greater than or equals to theta square over n. So dalam kes ni theta head is a uniformly minimum variance unbiased estimator of theta since it attains the Cramer round lower bound. Attains the Cramer round lower bound maksudnya value kamu tu boleh sama juga ataupun lebih besar lah. Greater than or equal lah ya. Biasanya kebanyakannya adalah sama dengan equality. Okay. theta head is a uniformly minimum variance unbiased estimator. Yeah. So this one is exponential distribution. Okay, again, first step, finding your expected value of theta head equals to theta. Okay. Second step, verify what is your variance theta head. Okay, dapatkan dulu. So kalau tak sure, integrate lah ya. So variance theta head, theta square over n. Okay. The next one, use the formula for Cramer-Rao lower bound. Okay. Ini single variable ya, fx. So ambil ln, differentiate second time. Then baru dapatkan expected value, tambah negative n kat depan, okay, to the power -1. So you get theta square over n. So in this case, this one attain your Cramer-Rao lower bound. So your theta head is a uniformly minimum variance unbiased estimator. Okay, ada apa-apa soalan? Boleh faham ke setakat ni?
Doktor.
Okay. Saya laju sangat ke? Okey ke? Yeah. Okay, kita tengok the next one eh. Okay, try this one. We try for Poisson distribution. Okay. Again, Poisson discrete eh. Dia tak semestinya untuk continuous saja. Okay. Okay, kita nak tunjukkan X bar. Okay. So again lah, dia punya proses tu sebenarnya. Okay. Proses dia, again lah kalau let's say kita ada soalan test lah ataupun soalan final eh. So biasanya kita akan verify and show that X bar is the MLE of lambda. So first step, dapatkan MLE dulu. Okay. Second, show that your X bar ataupun show that the answer in part 1, which is your MLE tu, okay, is the unbiased estimator of lambda. Okay. And then verify whether your value in part 1, okay, is a uniformly minimum variance unbiased estimator of lambda. Okay, maksudnya kamu kena dapatkan dulu apa dia punya MLE dia. Okay, katakan dalam kes ni X bar. Okay. So again kita nak tunjukkan X bar is uniformly minimum variance unbiased estimator. So sama juga prosedur. Tunjukkan dulu apa dia punya unbiased estimator dia. Okay. Is it X bar is unbiased estimator or not? And then find your variance. Dua benda tu dulu. Okay. So let's say if we get, ini pun samalah dalam before this punya exercise, you already verify EX bar is a estimator for your lambda. So the same concept, E summation xi over n. Okay. So kita ada 1 over n, and then you will have x1, x2, xn. Okay. So again, kat sini, properties for expected value 1 over n. So splitkan EX1 plus EX2 plus EXN. So EX is lambda eh. Okay. Properties for Poisson, kalau boleh hafal. EX lambda, variance X pun lambda. Kalau tidak, kena buktikan pula. Okay, kalau boleh hafal dia punya properties dia. So EX, so that's mean we have lambda plus lambda. Okay, all together you have n lambda. Cancel out with n. So again, unbiased. Yeah. So second step, finding your variance X bar. Variance X bar. So variance summation xi over n. Okay, follow properties for variance. Okay, basic properties for variance. Make sure Pak tahu kan. So 1 over n square. So variance summation xi. So same thing. Kita dah ada apa tadi? X1, xn. So setiap benda tu kita ada variance x dia lambda. So kamu akan ada n lambda. So you will have lambda over n. Okay, saya cancel out n, you will get lambda over n. Okay, so sekarang ni kita dah ada variance x bar equals to lambda over n. So bila kita nak verify dia adalah uniformly minimum variance unbiased estimate of lambda, so kita dah ada pemikiran di mana kita dah tahu dia punya Kramer round lower bound tu seboleh-bolehnya kita akan cuba dapat sama dengan lambda over n. Okay, supaya data ni lah kat sini. Okay, itu kita punya andaian lah. Kita assume kalau dia adalah uniformly minimum variance unbiased estimate of lambda, you should get also lambda over n for Kramer round lower bound. Okay, so next step, finding Kramer round lower bound. Step ketiga, CRLB. Okay. Start by sebab ini kita tak bagi dia punya apa probability function. So you need probability function So ini pun kalau boleh file lah Poisson distribution punya apa probability function. Okay. So, kita ada fx lambda exponential lambda to the power x divided by x factor x. Okay, that is your probability function for Poisson distribution. Okay, kita start dengan ambil ln. So ln fx lambda. So ln exponential negative lambda, you get negative lambda ln e. So ln e is equals to 1. So saya tak tulis So plus lambda to the power x, ambil ln. So x ln lambda minus ln x factorial. Okay, make sure you can write this one. Ini x Okay. Next, kita differentiate. Differentiate with respect to lambda. So you try differentiate. Kita differentiatekan. Bezakan lambda. So this one. So x. Bezakan ln lambda 1 over. Okay. So bezakan ln x tak ada apalah sebab tak ada lambda. 0 lah. Okay, that one. So katakan kamu nak differentiate sekali lagi. Differentiate one more time. Kita differentiate x over lambda Differentiate 1, 0. So that means this one you will get negative x over lambda square. Okay, differentiate 1 over lambda. So you get negative x over lambda square. Okay, so now get the value. Katakan kita ada negative n. Expected value, nak buat step by step, nak dapatkan expected value dulu pun boleh ataupun teruslah dah boleh. Over d lambda square. Okay, that is the formula. Okay, masukkan. So you will have negative n expected value negative x over lambda square. So again expected value of x, okay, negative hilang positive. So ex is just lambda. So cancel out, kamu akan dapatlah n over lambda minus 1. So dia akan dapat lambda over n. Okay. So again here tadi kita dah ada variance dia. So variance greater than or equals to lambda over n. Okay, so again, in this case, since it attains the Cramer-Rao lower bound, so S bar is a uniformly minimum variance unbiased estimator of